Hi engineers, in this lecture we are going to see about the polarization. So here at downside we can see a few applications of this polarization. Now in our syllabus we have what is polarization and then how many ways we can produce the polarization, and finally we have Nichols prism. This is a small chapter. Now, so what is polarizations? So whenever we take a light is having both electric and magnetic fields which are mutually perpendicularly vibrating. And in case of unpolarized light, its fields will vibrate in all the directions. But when we use the polarizer, this will get light to be polarized in a single direction. The property of one-sidedness is typically known as polarization. And another point we have to note is polarization takes place only in transverse waves. Longitudinal waves cannot produce polarizations. This is a specialty of the transverse waves. So in order to identify whether the given wave is a transverse or longitudinal, only one option is the polarization. Now we have different types of the polarization based on the vibration of the field. There is a linear polarization, circular polarization, and elliptical polarization. Polarization can be produced in a different methods by transmission. Polarization can produce it by reflection, by scattering, by refraction. These four methods we can use in order to produce the polarization light from unpolarized light. So whenever light falls on a medium, it will get reflected and some part will get refracted. So whenever the light is get reflected, it will get partially polarized. So there is a particular angle where the reflected light will get completely polarized, and that particular angle we call it as a Brewster's angle, and the law is known as Brewster's law. It says that the reflected light is fully polarized at a specific angle of incidence. So our idea is we have to identify specific angle of the incidence. So the angle between reflected and refracted rays is also 90 degrees by using this formula. Mu equal to tan IB. Mu is nothing but the refractive index of the medium. So this is known as a Brewster's law. In order to derive the mu equal to tan IB, we will take the help of Snell's law, where Snell's law says refractive index mu equal to sin I by sin R. So when a light is incident at a Brewster's angle, this is the angle of incidence. That's if it is falling with the Brewster's angle, then IB plus R. So this is IB, this is IB. So IB plus R plus 90. Total will be 180. So IB plus R is 90 degrees. From that, we will write R equal to 90 minus IB. So sin R can be written as, in the place of R, we will replace 90 minus IB. So sin 90 minus IB, if we write sin 90 minus, this will be in first quadrant. So it's a positive. Sin 90 will be cos IB. So this cos IB, we will substitute here in the Snell's law. That will give sin IB by cos IB is equal to mu equal to tan IB. This is nothing but the Brewster's law. Then we have a Malus law. This Malus law help us to study the light intensity relation. So whenever the light rays transmit through the polarizer, how much we will observe after that, and whenever it transmit through the analyzer, how much we will observe after that. This relation this Malus law provides. So what is mathematically we can say is equal to I is equal to I naught cos square phi, where I naught is the maximum intensity and phi is the angle between the light polarization and this axis. So typically we will use I is equal to I naught cos square phi in order to identify the intensity. Then we have another method, polarization by double refraction. So what is this double refraction? It is basically an optical properties of a crystals, basically single crystals. Whenever a light ray passes through it, it will get, or it will splits into two parts, two refracted rays that's each propagate in different directions. And these two rays are named as ordinary ray and extraordinary ray. So ordinary ray is known as O ray and extraordinary ray is known as E ray. So the phenomena of splitting of the light into two rays is known as double refraction. So this we can observe here when unpolarized light pass through the calcite crystal, it will get splitted into two refracted rays, and two are moving in different direction. Next one is when come to the applications of the polarization. Polarization has, as we started with the 3D movies, then identifying a transverse longitudinal waves, and not only that one, by using this phenomena, we can make a Polaroid filters, which are used in the stress analysis testing and infrared spectroscopy, seismology, and even to understand the chirality of organic molecules in chemistry labs. So like that, we have a different applications in our life. Thank you.